transformation of trig function. So we have a trig function down here. Now this is actually very similar to our transformations of, in fact, any function. The only difference is the trig function's just essentially drawn different. When we're doing transformations, we're dealing with a of the function. So instead of writing of the function, I'll actually write cos in, and that can also be replaced with sine or tangent. There are other ones, but these are the three you're probably going to work with most. Okay, and then from there you would have k multiplied by x subtract, I think d is what you guys use in here, so we'll do d, and then finally on the very outside of the function the plus c. Okay, so in the question they've given us how many of these letters A, K, D, and C have actual values for them? Could you tell in the question right above?
A.
Yeah, we have an A. Which one's A?
0.5.
Okay, that's our A function.
And then no C, I don't think.
Yeah, that's right. There's nothing on the outside here. That'd be after this, right? Outside brackets. Yeah. We have nothing there.
That's D, I think.
Will this be D? Now, is this added or subtracted to K or X?
No.
No, it's what?
So it's K.
Yeah, that's right. Because it's multiplied to be a K value. So there's no D value either. Okay. So what we have there is a K value. Okay. So the K value, we know are going to be horizontal stretches and compressions, and A values are going to be vertical stretches and compressions. We've done that before with our other functions, right? Now what they've given is, I believe they've given you actual values on how to put, change it for, oh no, they haven't done that. Okay, that's fine. What we'll do is we'll actually put a graph of our trig functions up here. So let's get, oh, this is a scale of 1. We don't want that. Axis of trig. Okay, these are in degrees. It'll be fine. We'll maybe even make one after in. I might have to zoom out a bit for this. Yeah, okay. So here we go. We have our graph, and it's in degrees right now. Okay. Now, if you remember our cos wave, do you know where it starts normally?
1.
Yeah, that's right. It starts at 1. At 90 degrees, what happens? 0.
And 1. Negative 1.
Yeah, negative 1.
And 0. And 1.
Good. Okay. So that is essentially it. And then that pattern would continue, right? So what we'll do is we're going to complete this all the way across. There you go. Okay. And we'll just do our best to fill in the waves. So here's our cos wave. Okay, so this is where y equals cos x. Okay, now what we've had is a horizontal. Now remember these, when we talk about stretches and compressions, we talk about when A, for instance, if A is greater than 1, it's a stretch, right? And when A is between 0 and 1, we have a compression. The opposite idea with our K value. Our K value, when K is greater than 1, we consider it being compressed. And when K is between 0 and 1, they call it a horizontal stretch. Okay? So, first thing we could technically work with is our A if we like. We'll make that a red one. So we'll only include the Y equals 0.5 cos x, okay? So we're going to do one step at a time. Well, what this does is this A affects the peaks and troughs, okay, and also the amplitude. The amplitude, see in this one here, the value in front of cos is technically 1, so the amplitude of this is 1. So from the equation of the axis, which runs through the middle of this, the amplitude is 1. It goes up 1 and down 1 at max, okay? Well, now because it's 0.5, remember we talked about how this is going to compress it? Well, it's going to become shorter, okay? Our zeros will still be the same, so we're not going to be shifting anywhere from there. So our 0 parts will all be the same, but our peaks and troughs won't be as high, okay? In this case, they'll actually be exactly half as high, so it'll be at 0.5. So we got 1, 2, 3, so like 1.5 here.
Wait, so A affects the vertical.
The vertical, yeah, exactly. So if you notice, vertically this has been compressed. It's no longer as high as it used to be. Okay, that is our y equals 0.5 cosacs. So that's a vertical compression to it. Now our k is greater than 1, so it's going to be a horizontal compression. Okay, so in other words, what we do with these now, so assume we're on the red cos wave. Okay, we've gone from the blue one to the red one. Now we've put in one of the transformations. We're going to have a compression, horizontal compression. So what's going to happen is the frequency of this, think of this like a wave. Our frequency is happening about these points here. Think of the frequency picking up now because it's been compressed. It's going to turn over more and more frequently. Okay, in fact, by a factor of 4. Okay, so now your x values, we're still going to be having x value at our 0, but all of our other x values are going to be, what you want to do is they're going to be divided by 4. Okay, now sometimes they use radians for this. Right now we're in degrees, and I think you guys might be focusing on radians, so we might want to actually do a little conversion here. Do you remember, let's see if we can't get them in. Yellow show up? No, not really. We'll do a little conversion here. Do you remember what 90 would be in terms of a radian, or 180? Yeah, so pi divided by 2. 180 would be pi, good. This would be,
I think 3 pi over 4 or 2.
Over 2, yeah. And this will become 2 pi. Good, okay. So sometimes when it's in this fraction form, it's a little easier because when we divide 90 by 4, you're looking at like a decimal number, right? But if I divide pi over 2 by 4, all I got to do is multiply, and we'll focus in here. So pi over 2, because this is a k compression by 4, we got to divide it by 4, right? That's our idea here. Okay, well, pi divided by 2 divided by 4, we turn that into, I'll write it in permanent, just so we can get that idea. Pi divided by 2 divided by 4 essentially becomes pi over 2 times 1 over 4. You just take that value and multiply it by the bottom. So it's going to become pi over 8. Okay, so pi over 8 might be a little easier to find than 90 divided by 4, which is a decimal value. Okay, so for argument's sake, what we're going to do is we're going to divide all of these major points, our pi values or our radians, by 4 in this case. So this becomes pi over 8. Okay, pi over 8 is probably, this is where we're going to have to kind of estimate. I'm not going to zoom in too much here, but this is a fourth of it. It's probably something like here. Okay, now that was the x value. Notice I divided the x value, because it was k, I divided the x value, pi over 2, by 4. Okay, just like with the a, I divided or multiplied the y value by 0.5. What about if when I'm at x equals 0 and I divide it by 4? Does this change at all? No, it's going to stay. So you can almost think of that as a reference point. That's going to be a reference point to where I'm going to draw everything, and the frequency is going to have to pick up from there. And just like the frequency is going to pick up from here. So we take all of those x values and divide them by 4. So we can say we have the very first step to this. Because we know our 0 doesn't change, and we're now at pi 1/8. Okay, we'll say that's at pi 1/8. Maybe we can zoom in a bit for this part. We're at pi 1/8 there, okay? Okay, well the next major step would be pi. Well, what's pi divided by 4? Think of that. Pi divided by 4 is essentially pi over 4, right? Well, pi over 4 looks like it's probably going to fall, because that's pi over 2, halfway between. So here's pi over 4. So this point here now comes all the way over here to pi over 4. So now we're down to here, okay? 3 pi over 2, well, really all we have to do for that point, that's another 0, right? That's when it comes back up to a 0. Well, 3 pi over 2 divided by 4 becomes 3 pi over 2 divided by 8. So it's actually going to be something like this, okay? We're squeezing it in right now. 2 pi divided by 4 is going to become what? Pi over 2, which is this point here. So if you notice, and that was this point we're talking about here, okay? So one cycle only took 2 pi now because we divided by 4. And then that frequency is going to happen every single time. The frequency of this can continue to pick up. So I can continue that pattern. I know that this is going to come back down here, this will be here, this will be here, and this will be here. So the frequency of this guy has increased fourfold. Okay? And we'll just kind of draw it out again. You'll see that this...
Okay, so after like we do up to 360, do we just continue that pattern?
Yeah, you just continue that pattern because to up to 360, well, in this case, 360 is a normal cycle. And I'm going to write in purple because this is our purple wave. Y is equal to, that's what our final answer should be, 0.5 cos for x, right? That's what the purple wave is. It's condensed both ways. 360 is an entire cycle for the normal cos wave. But once we've completed our x, our actual cycle only took 2 pi, or 90 degrees, you could say. It only took up to 90 degrees to continue the cycle. So once you've done one cycle, you could essentially just continue that pattern. If you want to continue to divide to solve it, you can. But as long as you can see the pattern, like I can tell that this is what's going to continue to happen. So we're going to keep going down and up, and the frequency of this is going to go down and up. And that's what a frequency of that wave is going to look like. Okay, so it's being compressed to up there. So, well, that's the idea of a compression. That's what's strictly A and K. C and D would shift this up and down, right? So we have that information. What was the other part you were missing? Do you remember?
The curve, the axis of the curve, equation of the curve.
Equation of the curve?
Axis, yeah.
Equation of the axis. Oh, okay. Equation of the axis, you have to solve by taking the peak. Okay, so here's one of the peaks. And the trough, the lowest part, right?
Or the maximum.
Maximum, yeah. That's another way to call them. So max and min is another way to call it. Very good, okay? So those are our y values. Well, what is our max y value here? What does it get up to?
0.5.
Yeah, our max is 0.5, okay? And what's our minimum?
Negative 0.5?
Yeah, that's right. Min, negative 0.5, okay? So what you do in this one here, so if we take the two, we're going to add them together. So you take your max plus your min, add them together, and divide by 2. And that's going to give you the middle of this. Okay? So when we add them together, we get 0 divided by 2, which is 0. So the equation, so we call it EOA, equation of the axis, is when y is equal to 0. And that makes sense. That's right through the middle of this. Okay? Another thing they might ask you is for the amplitude. Another way you could find amplitude, we'll call it amp, is the exact same idea, except you do max minus min divided by 2. Okay? So let's think about that. Well, that'd be 0.5 subtract 0.5. So what would that give us? 0.5 subtract negative 0.5.
You add them.
Add them. What is that going to give us?
1.
1. So we get 1 over 2, or also known as 0.5, which makes sense. That is our amplitude. Our amplitude is 0.5. We know that by looking at A. Okay, so that's another way you can kind of work through those with those types of questions. Were there any other major things? There was no horizontal translation, and there was no vertical translation. The period. How long does a cycle take? How long does it take for our new one, this whole cycle?
90.
Yeah, you could say it either took 90 degrees or it took pi 2 in terms of radians to complete a cycle. All we got to see is when whatever our starting point is when we get back to there in the same way, right? So that's what we got for our cycle.
But when they ask for period, are they asking the original or just the final?
No, the final. Yeah, the original period's very obvious. It's always 360, so then all your answers would be 360, right? So they're just asking for the new one.